Hello guys, my name is Lazaro and today we're going to be doing a LeetCode problem. This problem is called stickers to spell word. You're given n different types of stickers. Each sticker has a lowercase English word on it. You would like to spell out the given string target by cutting individual letters from your collection of stickers and rearranging them. You can use each sticker more than once if you want, and you have infinite quantities of each sticker. So this sentence right here is pretty useful. It tells us that for every single sticker in our stickers array, we can use it more than once. It doesn't have to be a one-time use type of scenario. And this is also pretty nice right here, uh, where they tell us that we have infinite quantities of each sticker. This pretty much makes the problem a little bit easier by dropping the constraint and not having us to worry about how many of these stickers we've used. Return the minimum number of stickers that you need to spell out target. If the task is impossible, return -1. Note: in all test cases, all words are chosen randomly from the 1,000 most common US English words, and target was chosen as a concatenation of two random words. Cool. So we know what our output is supposed to be, the minimum number of stickers that we need to spell out target, this target word. And this task is either possible or impossible. If it's possible, return that minimum number, and if it's impossible, just return -1. So for example, here in example number 1, our stickers are with, example, and science. So we have a sticker that is the word with, a sticker that is the word example, and a sticker that is the word science. And our target is to spell out the word the hat, together with no space. Now we can successfully do this by choosing the sticker with twice. That way we'll have two T's and then two H's. So we would be able to use or be able to fulfill these characters right here inside the target word, the TH and then the HT. But then we're left with the E and A. So we need to use another sticker, and that other sticker that we want to use is example. Example has an E and also has an A, so a combination of two with stickers and one example sticker will be the minimum number of stickers that we need to spell out the hat, or to spell out this target word. So let's get right into the drawing. Uh, as you guys will see, although this is labeled as a hard problem, it's actually quite simple in terms of what we want to do, or what we need to do to solve the problem. So let's write out our stickers array. Alright, perfect. So one of the most important things that we want to do to solve this is that we actually want to figure out the frequency of these characters inside of target. That will make our life much easier instead of actually trying to put together a, a string that matches the target string with the characters we've seen in our stickers so far. Let's just try to see if we can, let's create a hash map, right? Where T, the character T, that is seen twice. Character H is also seen twice. E is seen once. And then A is seen once. So we can call this, for example, our frequency. It'll be much easier if we can bring all of these frequencies down to 0. If we can successfully do that, then if we are keeping track of the stickers that we used to accomplish that, then our goal is now to minimize that number. And we can simply use a global variable, or just make sure we're returning the minimum number inside of a recursive function that we created to handle this function, or to handle this computation. Now, since I said that we can use a sticker multiple times, that means if once we're starting with, yeah, that's pretty funny. Once we're starting with, let's look at the word with and see if there's any character inside of this word or any character in this sticker that is also inside of the target word. If it is, then we know we would want to potentially use it. So now let's actually use it. So for example, T will be dropped down to 1, H will be dropped down to 1, E remains the same, and A also remains the same. So if we use the sticker with, then this will be our remaining frequency. So once we have this updated frequency hash map, we want to call this recursive function that's handling this computation with this new hash map. And since we can use with multiple times, instead of just iterating now with two, instead of iterating for the rest of the stickers, we want to iterate still over the whole array. And this is pretty much the main gist of this problem. As soon as we have uh, a frequency hash map where it's all the values are 0, then we know that we have finished or that we're done. Now this is pretty simple in itself, but there's one more important thing that's really needed for this problem to be accepted, or for our algorithm to be accepted. And that is that we're going to need memoization to solve this problem. There might be multiple times where we see a frequency table like this, where there's only one T, one H, one E, and then one A. There might be a dozen times or hundreds of times, but this is a drawback and it could slow our algorithm just enough where we get time limit exceeded. So what we want to implement is memoization. We want to have some sort of memoization hash map that if we've previously seen this frequency hash map for the target word, then return the minimum number that we got when we computed this table, this frequency table. That will save us from having to redo a whole bunch of work, and that would allow our algorithm to be accepted. So now you guys might be asking, well, if we're using memoization for a table, we can't have the key be a hash map. A key needs to be something that's hashable. So something we can do is actually turn this hash map into a string. One way we can turn this into a string is just have T1, H1, E1, then A1. So just the key value as a string, and they're all joined together with no spaces in between. The reason why we don't want spaces is because if we have this hash, then we can easily test whether all of these values are 0 by just checking if our string, or this hashed string right here, is empty. The reason we're checking if it's empty instead of checking if we have something, if you guys are asking, we can have something like this, where T is 0, and then H is 0, and E is 0, and then A is 0. If you guys are wondering if we can have something like this, the answer will be no. The reason the answer is no okay, there we go. The reason the answer is no is because if we were to use a second with, then the T and H will be dropped to 0. Therefore, it won't be included. We would exclude it from our hash map or our next hash map. Therefore, by the time we use with twice and then we use example once, we will have an empty hash map, and this will result in an empty hash string. Now, when do we know to move on to example and stop looking at with? Well, like I said, once there's not a single character inside of with that can reduce a frequency of a character inside our hash map, then we move to the next element and consider that one. And this is all that's needed to solve this problem. The most important thing is memoization and this frequency hash table that's updated every single time we use a sticker. So now that we talked about this, let's get into the code and let's see how it looks like. So just like the other problem we did, where it was called letter tile permutations, I believe, uh, this is also backtracking. The reason it's backtracking is because, let's say we use with and then we use example and then science doesn't happen to work out, then we would backtrack to example and maybe consider another sticker if there was one after science. Let's say it was called art. We might consider with example and art, excluding science. So this is a pretty big problem where it brings in this DP aspect, dynamic programming aspect of using memoization. So we need memoization and we also need backtracking. But as you guys just saw, the problem itself is not actually that difficult to understand or to figure out an algorithm that would work. The problem is always the code, but we can work on that with some reasoning. Now, like we said, we are going to be needed a memoization, a hash map. So I use her initialize this right here. And we're also going to want to get the frequency hash map of the target word. Since we're going to be getting the frequency table of the target and the frequency table of stickers as well, I'm just create a new function right here, and I'm just going to call it getFrequency. We're going to be receiving S, which stands for a string. From this S, we can build out our frequency hash map. So for every character in S, let's get the current count inside of our frequency hash map for that character, and if it's not there, let's default to 0. Now let's set this equal to count plus 1. And then finally, let's just return frequency. So now we have our memoization. Let's also get the frequency table of our target. Perfect. Now let's work on this function or this recursive function that's going to be doing the majority of our work. So the first thing we want to do is create this hash string from our frequency hash map. And like I said, we just want to take all the key value pairs, put them in a string separated by colon, and then put all of the strings into one big string. Python, I'm just going to be formatting it like this. Let me make it a little bit pretty. For char freak in freaks.items. There we go. So that's just one nice way of doing it in Python, all in one line. Now, if not freak hash, this means that the frequency hash is empty. If this is the case, that means that we have seen every character in the target word the proper amount of times with the stickers we've seen or with the stickers we've used. So if this is empty, let's just return 0. And you see why we are returning 0 in a couple of lines. Else, if something else that we want to check is if the frequency hash is inside our memoization hash map or hash table. If it is, let's just return whatever we previously computed for this frequency. Now in the beginning, our answers will be equal to infinity, and our main objective is to minimize this. So now we want to look at every single sticker in our stickers array, and we want to get the frequency of the sticker. There we go. So let's get the frequency of this sticker, aka if the sticker is currently with, we'll get a hash map that has a key of W with the frequency of 1, then I1, T1, H1. It's the exact same thing we did for the target right here. Now we want to make sure that there's at least one character inside of this sticker that is also inside of the frequency, the current frequency that we have. So let's just do char in freq, and we can check for that all in one line as well by seeing if there's a character in freaks for character in stickers. So for every character in stickers, if that character is inside our frequency table, our current frequency table, uh, this would return a array of booleans, and if any boolean inside of this array is true, then char in freq will be set equal to true. That's what this any function does. Now we can break this up into multiple lines, but I'm just going to leave it as one. Now, if there's a character inside of our sticker word that is also inside of our frequency table, then we want to consider it. And first, we want to build this new frequency table by subtracting the frequency of the sticker and the current frequencies. Now, I can also just do this in one line, but I'm going to break it up. Sorry, not in one line. I can do this in a couple of lines right here, but I'm just going to break it up into a function. So let's call this subtract frequencies. So we'll get the target frequency, and then the sticker frequency. The new frequency is going to be like empty. Then for every character in frequency in the target frequency table, we also want to get the frequency of this character inside the sticker frequency. And if it's not there, let's default to 0. Let's also calculate the difference by taking the current frequency of this character inside the target and subtract it by the frequency of this character in our sticker. If this difference is greater than 0, then let's add it to our new frequency table. Else, if it's less than 0, then let's just not add it at all because we know we have taken care of it and we no longer need to worry about it. After this, let's just return new frequency. So now let's call that right here. The first one is be the freaks. This freaks, remember guys, this freaks represents the current character frequency hash map for up to this point. For every single sticker we've considered, what are the remaining characters and their frequency for the target word. The first parameter is freaks, and then the second parameter is sticker freaks. There we go. Now we want to recursively call this function, so let's set ans is going to be equal to min between what we currently have and whatever this recursive function returns. But we do want to do +1 because if we're calling this function recursively, that means we considered this current sticker we're on. That's where the +1 is coming from. And that's why here we're returning 0. So let's say the target's the hat, right? And the first sticker is also the hat. Well, once we calculate this new frequency table, everything will be 0. This if would execute and we would return 0. But then 0 plus 1, where this +1 is coming from the fact that we took the first sticker, would result in just 1. And that's what we expect and that's what we want. Now after that for loop, we just want to add this computation to our memoization in case it's later needed. And then finally we can just return answer. Now we want to call this function with our initial target frequency table that we calculate right up here. And if this answer is float infinite, we know that we were not at all able to use any stickers to build this target string. And here they're saying that if it's impossible to do this task, just return -1. Therefore, we'll do exactly that. Else, we just return answer. Now let's run this code to make sure I didn't make any mistakes or anywhere. And I did. So let's run through this and see if we can find it. Alright, so found mistake is for speed for character in sticker, not stickers. So let's run this one more time. See if that was the only mistake I made. No, there was another one. Ah, missed an S. Any more? Nope, perfect. So now let's submit and see if it gets accepted. And it does, perfect. So hopefully you guys were able to understand how to solve this problem. It was labeled as hard, but as you guys can clearly see, it's not really the most difficult problem to solve. I think the main thing that most people end up missing is the need for a memoization hash map, because we may end up seeing the same frequency multiple times, and we don't want to redo that work. So other than that, hopefully you guys enjoyed the video. If you did, leave a like and consider subscribing, and thank you for watching.